Welcome to the lecture number 19 of the deep learning course. In this session, we are going to talk about a very interesting and very important concept that people talk about uh, very much is CNN. We are going to talk about that. So hope I'm audible and everything is fine. So let me go and start by this discussion by having a small problem. And the problem is very easy that you know that if there is any signal and you want to estimate that particular signal. Okay, so let's assume that this is what the signal is. Let's assume that there is some signal like this. Okay, I'm not sure about this what it is later, but let's assume that there is some signal this particular kind, and you want to estimate it. So how can you estimate it? The um, the basic idea would be that you have to deploy some kind of sensor to get the data, and if you deploy a sensor, so sensor has noise. You know that every sensor has a noise. So what would happen that you are most probably what you want to do that at a regular interval you are going to see that what is over there. Even if it is a video, you know that you video is a 25 frame per second, so it is not continuous thing. So after 1 upon 25 seconds only you go and see that what is in front of you. So here, if you want to find out that what is the value over here, so most probably what value you are going to get. So you know that this is the actual value, this is the actual value, but because of the noise, you may be getting this value, you may be getting this value. So in the same way, if you wanted to estimate this particular point, so you are going to get this. So in the same way, you wanted to estimate this point that was this, and but you got this point. So you are not going to get the same thing. Okay, so ultimately if I want to say that you are going to get something like this, okay, the point would be something like this. So what is going to happen that if you want to estimate the things, you are going to get the signal. Okay, you are going to get this signal. This the right signal? No, this is not the right signal. So how can you get the actual signal? This is what the problem is, that uh, if you want to find out the actual value estimates, so how can you estimate the actual readings? You know that most probably the noise that you are going to see is going to be Gaussian, because we know that most of the general phenomena are actually Gaussian, and it is zero centered. So you expect that the values are going to be a kind of this, where the if you want to see that how much variance you are going to get, so the variance of this particular quantity, for example, how much, whether you are going to get this variance or this variance or this variance, so you can fit in Gaussian on that. You say that it is going to be a zero centered Gaussian that actually can give you that what is the value. And most of the time if you have this kind of assumption, then summation of all the of the this particular thing is going to be zero. So summation means what? Expected values. If you want to find out the expected value of the signal, it is going to be zero. And here in terms of the signal, I say that expected value of the noise is going to be zero. So if multiple values are given to you, if multiple values are given to you and you want to find out a particular the estimation, the idea is this, that along with the sensor you have to measure some of the quantities and put the average of this quantity at this particular place. Once again, at this particular point, if I want to find out the actual value, it would be nice that if you find out that what is the value into this particular duration and you put the average of that particular quantity at this particular place. So this kind of smoothing is most probably is going to give you the actual idea of the actual signal. Make sense? So this is not a new thing for you. So we have discussed this, that the average of the sum of the reading, if you take the average of the readings, so into the local neighborhood only, because if you because global neighborhood means what, that for all the values you find out that what is the average and put the same value across. So this is not a good idea. So you take the small, you define some local neighborhood, and in that local neighborhood only you find out that what is the average value and you are going to put that particular place. uh, so this idea is this, that let me go back and here tell. So here what I you would be expecting, that you would be getting the something very similar to that. And here my point was this, that what I wanted to tell is this, that the signal Let me just only represent the time. Okay, with respect to the time, you are going, if you want to find out what value should be here, so you are going to see the local neighborhood, and you are going to put the average over here. Average is defined by some set of value. For example, if I say that I am going to take 20 values, so it is going to 1 upon 20 and summation of all the values which are actually here. So 20 values means what? Let me also make it simplified and say that only 5 values. So maybe here the value v minus 2, and v, let me write like this. Let me say, 1 minute. Let me say that you want to find out the value at this particular thing. Okay, so let me call it, you want to find out v0. So you have to see that what is v minus 1, what is a v minus 2, v1 and v2, and what you are going to do, that what is our proposal? Our proposal is this, that you are going to find out the summation of all this quantity. You are going to find out the summation of all this quantity, and then put 1 upon 5 and say that this is going to be the value of v0. Make sense? In the last class, we have seen that these kind of methods which actually do the simple kind of averaging, they have a problem that they introduce blur to the signal. However, we have seen that if somehow we can say that this v1 is very important, so I say that 5 multiplied by v1, v sorry v0, v1 is less important, I say that 3 multiplied by v1. So similarly 3 multiplied by v minus 1, and v2 I can say that only one weight is given to that. So I can write a weighted equation in this way, that I can say that v2 plus 3v minus 1 v minus 2 plus 5v0 plus 3v1 plus v2. This is another way to write the same thing, where I have put the weights on that. And when I put the weights on the things, and most probably this particular thing I wanted to show you that it is into the form of a Gaussian. So they have a different kind of behavior, and this behavior is called enhancement. This behavior actually gives you the enhancement. Why it gives you the enhancement? So in the last class, we have seen that there was a image on which actually we have applied a box filter, means we have applied a averaging thing, and then we have on the original signal, let me call it I, let me call it box to IB. So what we have find out, that we have seen the difference between I minus IB, what is the difference of this particular quantity, and then we have actually added original signal plus to alpha time I minus IB. We have done this particular thing. So what does it mean? It actually, what was the effect of this particular quantity that we have done in the last class? That actually we have seen that when actually we determined this particular quantity, this was giving us the details of the thing. Why it was giving the detail? Once again, let me tell you that in there was a, recall that there was a image of the owl we have shown, and we applied a different kind of filters on that. In the last class, we have also discussed this particular thing, that if we change the size of the filter, if we change the size of the filter, what happens? That filter try to pick the items which are of this particular size. Okay, anything that is of the lesser size is actually not that much relevant for a particular box kind of filter. So what happens, that if you say that if you if you just concentrate on this particular quantity here, IB means what? The box filter means what has been destroyed, anything that is of the size less than 3 is being destroyed. Okay, let's assume that I have applied the box filter that we have applied is, for example, 5 plus 5. So anything that is of the size lesser than 5 plus 0.5 is actually destroyed into the new image, this in new part. So if you find out the subtraction, means what? This original image has all the component, and this has only the higher component which are actually bigger than the 5. So what is the difference? Difference is that what is the things which are actually lesser than the 5 cross 5. So in the image, anything that is actually of the smaller size means what? It has a details. Okay. So bigger things not this particular quantity is going to tell you what, that what are the details into the image. If you add details to the particular image by multiplying some with using some kind of factors, so this image that we are going to get, we have seen that the image got enhanced. So this is the basic idea, that by this you can do the enhancement. So this you can say that it is going to be alpha plus 1 time I minus alpha time IB, something like that. This equation comes out into this particular thing. So 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 this behavior that I was telling you, that if you apply a kind of weighted average to the system, where I am going to say that you are going to multiply the things which are actually means for the different thing. If you are going to multiply a weight also, that for this particular position there is some weight 0 here, weight -1 here, weight -2, weight 1, weight 2. So if you apply the weight on that particular thing with the thing, and then if you see that what is the value that is going to be given to you, it is a kind of enhanced value that you are going to get over there. So many of the time, if you find out the right kind of weights in your system is going to behave better. This is what my point is, that if you find out that what are the right kind of weights, and then you find out the average using that, your system is going to behave better. So here is an example where a simple running example that was just to show you something, that let's assume that this is the data that is coming to you, and you have actually come up with a kind of a weight matrix as this. And then if I want to ask you that what value you should produce. So here, what is the size of the weight in this example? 1, 2, 3, 4, 5, 6, 7. So let's assume that this is what the data is coming to you, and X is the data that is coming to you. So what are the values? So I'm just going to read this. So 1, 1, this some value is going to come to you, and you want to apply the same kind of mechanism into the system to find out the actual good values out of that. If your weight is of this particular size, so can you find out the weight over here? Can you find out that what should be the right value over here? Probably not, because these values are not available to you. How can you multiply up with, because these many number of values are, if you have, then only you can apply with these weights and get the output. So you have to wait until you get the enough number of samples uh, uh, to be multiplied with the weights, and then only you can say that what is my output. So here, let's assume that when you are at this particular moment, and then you can start producing the output. So at this time there was no output, but after that you keep producing the output until whatever number of item is given to you can produce the output. This is nothing bad concept. Most of the time you see that any system that you have, you can say that it is a kind of cold start arrangement, where initially you don't have the data, but after that you got the data. Okay, so I want to find out that what should be the output at this particular place. Okay, I want to find out that should be the output at this particular place. So for that I have to see that what are the previous values. So previous values are 1, 1.1. So let me write 1.0, 1.1, 1.2, 1.4, 1.7, 1.8, and 1.9. All these values need to be multiplied by what? By a weight, and these weights are here. So I say that they are multiplied by 0.01, it is multiplied by 0.01, multiplied by 0.02, multiplied by 0.02, multiplied by 0.04, multiplied by 0.4, multiplied by 0.5. Sorry, 0.5. So can you help me to find out what is this value? Okay, can you help me to find out what is this value? And then subsequently, what is the summation? It comes out to be 1.80. So instead of 1.90, which was actually coming over here, you are going to say that it is 1.80. And subsequently, for the next item, if I ask you that what is the value over here, you can do the computation and tell me that what is the value that is going to be here. So this is the way in which a weighted window you can utilize, and you can get a better estimate of the actual data. So it's actually in this particular system, in this particular example, this particular weight actually serves us to find out the better estimate of the actual values from the sensor. All right. So Here the things are into the one dimension only, because you can see that all the things are, because one dimension values is coming, so your weight vector is also one dimension. In case of images, image is a two dimensional data, so where x and y coordinate both are there. So here your weight vector that you want to multiply also need to be of the two dimension. Okay, so we have seen this, that maybe this particular thing which has the which is a 3x3 values, you can utilize this to be applied on this particular image. Okay, so here if I want to find out that what is the value, so if I want to apply a filter and I want to get a something else, so what would happen, that if you apply the filter, what is you are going to get, you are going to get a different image. So at this place, what is the value I am going to get? If I want to find out that what is the value that I am going to get at this particular place, so maybe I should write to this particular way. So let's assume that this is what the image is. Okay, let me say that this is what the image is. Okay, and my question is that what is the value that I'm going to get here? Once again, it is going to be the same concept, that if your filter is of this 3x3, you cannot apply this thing over here, because then what you need, so if you want the value over here, so let me use a different color. So let me use a different color. I use this color to say this. So I have to put this thing to find out this value. I have to put it here like this. So let me also put this, that I say that this value I wanted to find out. Okay. So you put this particular filter over here and try to find out the value. It is going to be very difficult because nearby values, you can see that these values are not available because they are not into the image. So you cannot find out this particular quantity. Make sense? So first thing, that first value that you can get is here. Okay. Can you see this? You cannot find out even this value, even this value. These values are not available. Similarly, these values would also be not available. The first value that you can get is going to be given by this. And how can you find out this particular quantity? Once again, what I was telling that first value that you can get is this value, and this is going to be what is the pixel value over here and what is inside this particular filter. You multiply this, you multiply this, you multiply this, you multiply this, so whatever value summation you are going to get, you are going to put at this particular place. The operation is called convolution. This particular operation is called convolution. So let me think that this particular image, that the image that you have is of L cross B, number of pixel. Okay, L cross B. If the image is of L cross B, let's assume that image is class L cross B, and this filter is of something size, say I say that 2k plus 1, f is equal to 2k plus 1. What is 2k plus 1? So you know that most of the time we want the filters to be of the odd size, so that there is a middle pixel on which actually you want to find out. For example, 3x3, if it is a 3x3 filter, then what is the value of k? K is equal to 1. Okay, so here it is a 3x3 pixel. You want to find out that what is the value at this particular place. So one value is here and one value is here. So k is equal to 1. So you can say that k is equal to 1. Similarly, one line is here, one line is here. So you can say that k is equal to 1. Another filter could be 3 cross. After 3 cross 3, you can say that filter is 5 cross 5. If your filter is 5 cross 5, then k is equal to 2. So here the things would be this, that if it is like this, you see that like this, the 5 cross 5 filter. Here you want to find out this. So if the k is equal to, it is 7 cross 7. Now I have made it 7 cross 7. So 5 cross 5 is this. Okay, 5 cross 5 is this. Okay, this is the 5 cross 5. Similarly, this one is the 7 cross 7. This is the 7 cross 7 filter. Okay. Uh, so I was talking, what I was talking about, I was talking about that if you apply a filter, you cannot get the equivalent value from this at this particular location. You have to start over here. So how much you have to shift? Any idea? How much you have to shift? So if it is a if the filter is off, if I say that filter is equal to 2k plus 1, I represent by this idea, then k number of things you have to leave at this particular side into the left side, and k items you have to leave at the right hand side. So this value you have to, this is the first value that you are going to get. This is the first value you are going to get. K values you have to leave. You cannot find out the equivalent thing for them. Am I right? Yes or no? Yes. Okay. So, and in the same way, if you keep finding out what is the value of next pixel, you can find out. Similarly, you can find out over there. So here also at the end, you have to leave the k pixels. So k pixels, you cannot find the values for them as well. Am I right? So the image after applying this filter becomes of this particular size. Okay. So k values are here not available. K values are in this side also not available. Similarly, on both the side left and right, these k values are not available. So an image that is of the size L cross B becomes of what size? L minus 2k multiplied by B minus B minus 2k. Any problem on that? So the size of image actually reduces. When you apply a kind of filter on that, the size of image reduces. Any questions on that? Yes or no? Make sense? Yes? Can I write yes or no? Yes? Uh, I can do a small mathematical change over here. I can say that 2k is equal to f minus 1. So if I use this particular notion, because f can directly can tell me that what is the size of the thing, then here we are talking about the symmetric filters. So instead of 2k, I can write f minus 1. So this equation becomes L minus f minus 1 times b minus f minus 1. Okay, I can say this also. So after this thing, I have written this. So what does it mean? It is L minus f plus 1 times b minus f plus 1. I can say that's this also. So if what is the size of the image after multiplying a filter of f is equal to k plus 1? So you can say like this. Any questions on that? Yes or no? Fine. Okay. So sometime it may be possible that that you say that these values are not available. So I would do what? Because you can say that that this value are not available. Why it was not available? Because few values it need to do a multiplication over here, they were not available. So if I say that, okay, let me do some kind of arrangement, let me put p number of pixels over here. P means padding number of pixels over here. So what does it mean? That hypothetically I have added p more pixels in this particular side, in both the sides, and therefore the size of image actually increased. So maybe I can put the p in such a way, or what is the value, by the way, what is the value I'm going to put it here? Maybe there could be two kind of possibilities. I can say that either I'm going to put all the values as 0, or I can put the whatever the previous value is there, I could put the same value over here. Okay. So both the things are possible, because ultimately what happens most of the time, if you want to find out anything inside the image, you are not going to much bother about this particular thing. Whenever you do the padding, you are your most of the time your objective would be to maintain the size of the things only. Okay, because we think that when the image has been taken, the item would be inside, so border anyway not that is not that much important, but to make the system working into the perfect way, we sometimes we add the paddings. So if I add the padding, for example, in this particular case, when my mask was, this particular filter was 3 cross 3, if I p is equal to 1, if my p was 1, so these values are also available. Okay, so if you want to find out this particular quantity, this particular value, can you find out this now? Yes, because here values are available. Even if they are 0, no problem, you can multiply and get that value. So earlier this value was not possible, but now this value is possible if I add some kind of padding on that. If I put a padding, the padding is what? P, and whenever I do a padding, I add the padding in both the sides, okay, in all the sides. So what happens, that ultimately what happens now, the length which was actually earlier L becomes L plus 2P. Breadth which was earlier B becomes L plus 2B. So if I ask from you that L cross B was the size of the original image, and if I add the padding is equal to P, then what should be the final image size? Can you tell me? The final image size would be, instead of L, you should write L plus 2P. So it is L plus 2P minus F plus 1 multiplied by B plus 2P minus F plus 1. Am I right? With the padding is equal to P, if you apply a filter of size F, this is what the size of next new size of the image that you are going to get. Any problem, any questions on that? Any questions on that? Yes or no? Any questions? Parth, Srijan, Akshit, is it clear? Clear? No question? Okay. So the same thing is written over here in a mathematical way, and it is just a matter of symbol, that if you want to find out a Sij, where I and k are, I is an image and k is a filter, you multiply, and ij location you find out that what is the value at the ij location. So you can run a something from 0 to m minus 1, 0 to n minus 1. You say that I you take the I and k, and corresponding values you are going to multiply, and here k is AB location of the filter, and you are taking from the image, you are going to take the a plus I and j plus b. So here this notion is actually going to tell that if you want to find out at this particular place, this you are going to multiply into this particular way. No issues in this. I think this is the better formula. I think if you see this formula, it would be more natural formula for you. You say that if you want to find out that what is the ijth location, what is the value, you say that from minus m by 2 to m by 2, where m is actually here the size of this filter. Here again f is equal to, I'm telling that m is the size, so half of the m is what? Minus half of m by 2. M by 2 means half of that particular quantity. Half of that particular quantity is, again, you take the lower of ceiling of that particular quantity is going to give you the k. So it is essentially minus k2 plus k. You are finding out that what is the image and what is this particular filter. You are term by term multiplying and getting the answer. Again, this is an example where actually I have this as an input image and this as a kernel. So what is the input image? It is of the size of what? 3 cross 4. And what is the kernel? It is 2 cross 2. So f is equal to what? 2. So if you apply a filter of size f on the image of cross L cross B, what is the output that you get? So you know that output is going to be, you can find out using this particular formula. What is this? L minus F plus 1, B minus F plus 1. So you can say that it is L minus F plus 1 into B minus F plus 1. This is the size that you are going to get. And here L is equal to 3. So 3 minus 2 plus 1 into 3 minus 2 plus 1. And it is a 2 cross 2. It is 2 cross 3 minus 2 plus 1. Am I right? I think I am writing wrong here. B is equal to 4. So it is 4 minus 2. So it becomes 3. 2 cross 3. So you can see that the output that we get is 2 cross 3. Okay. Any questions on that? So here once again, if you want to, again, let me just just for the sake of completeness, let me just do this particular part for you. That you have an image, this particular image, and this is the kernel WZYZ. So you what you do, that you put this thing over here to find out the value. Okay, so you say that W, X, Y, and Z, you put multiply over here, and it says that whatever value you are going to get, you are going to put at this particular place. Then you shift it here, so it becomes, then you shift it here, and you get the next value. Okay, here you get the next value at this particular location. Again, you are going to shift this thing once again, one more place, and you are going to get the third value. Okay, and the equation that you are going to get, CW plus DX plus GY plus HZ. Okay, then again you have to shift this over this place. So EW, so you can see that, see here, EW and FX and YI and JZ. This is how you are going to get. So you all know that this is the next item, this is the next item. By this you find out this particular array. This is how we do the matrix multiplication, and when you apply a CNN into the system. Any questions on that? Uh, let me tell you one more thing at this particular place. That hypothetical example, let me give you to you, just to increase your understanding. So this is a needed, very needed, important example. Let me go back, try to see that if I have more space. No. So let me add a page. Okay. Okay. So let me give you a very simple example where I'm telling that, let's assume that I have an okay, let me put the value, say 20, 20, 20, 20, 20, 20. Let me create an image, and I say that copy, paste. Let me say that these values are 20, 20. Every time I do wrong thing only. Today what is happening? Okay, just give me 1 minute. Okay, I would draw it once again in the right way. So what I wanted to say, that 20, 20, 20, 20, 20, 20, 20. If I say that these are the values I have, and let me copy it, paste, say that again these are the 20, 20, paste. Let me say that here also I have 20, 20. Okay, so if I again paste something, paste again, I have 20, 20. Let's assume that this is how I have. Then next values, let me say that 50, 50, 50, 50, 50, 50, 50. Let me copy it, copy, paste. Let me show you this image. Okay, how this image looks like to you. So if this is the image, can you visualize this image? Let's assume that this is the image. Can you visualize this image? Yes. Can you visualize this image? So if you try to, let me just also copy this 1 minute. Copy just for the sake of completer, paste here. Okay, I would use this later. If you try to visualize this, it looks like that there is one intensity which is actually here, and some higher intensity on the other thing. So this is how you are going to visualize this. Okay, this is how you are going to visualize it. Maybe the higher intensity. This is how. Okay. Okay. Uh, what as a feature is important over here? Can you think that anything as a feature is important into this particular thing? If I want to find out that what is the feature, what is the main thing into this particular diagram? So let's assume that we don't understand this part. So let me apply a kind of filter, and very simple filter I'm going to apply at this particular moment. And this filter is -1, -1, -1, 1, 1, 1, 0, 0, 0. I'm sorry. I'm very sorry. So if I apply this filter into this, so let me, if I apply this filter, what are the values that I'm going to get? Can you help me to find out that? So if let's forget about the border cases, just see that what is the value I'm going to get at this particular moment, at this particular place. So if I put this particular thing over here, so -1, all these values are going to be multiplied by 0. So they are not going to do anything with the summation. Because of +1 and -1, they are subtracted and I get what? I get 0. So ultimately, what is the value that I'm going to get at this particular place? Can anybody suggest me? So I would get 0 here. Okay. I would get 0 here, 0 here, 0 here, 0 here, 0 here, 0 here. All these places I would get 0. Am I right or not? Similarly, if you want to see that what value I am going to get in this particular place, again I am going to get what? 0, 0, 0. By chance I have to only remove 5. I get 0 value over here. So let me not focus on this, because ultimately I told you that they are the part of borders. I'm not much interested what is happening over here. So I'm removing here. Okay. What is the value that I get? So once again, what is the value here? Again here all these 0. So third line is also 0. Similarly here I got what? 0. If I ask you that what is here, again it is going to be 0. So in this line also I get everywhere 0. Everybody with me? I get 0 values over here. I get 0 values over here. But if I ask you that what is the value that I'm going to get at this particular place? Again, when I put this filter over here, these values are going to be multiplied with the 0. So I get 0. So 20, 50, 20, 50, 20, 50, 20, 50. So it is going to be the 50 minus 20. 50 minus 20 is how much? 50 minus 20 is how much? 30. And let me also assume that there is 1 by 3 is also written over there. So I get here what? 30. Am I right? So here in all these places what I get? I get 30. 30, 30, 30, 30, 30, 30, 30. Am I right? Yes or no? So if I ask you that what value I am going to get over here, it is again 50 minus 20. Here also I am going to get what? 30. So this is again going to be 30, 30, 30, 30, 30, 30, 30. Okay. So can you visualize this image? Can you visualize this image? Looks like that here is a strip. Okay, looks like that here is a line. Hmm? Anyway, if somebody gives you this particular image, you would not understand if you would not draw any feature from here. What is important? Only important thing is here, and what is important over here is a line. Can you see that? Can you see that? It comes to your understanding that looks like that here is a line. So this particular kind of filter, which actually I have applied on this particular thing, has given me a feature that here is a line. And the things where it was not important, he has removed this particular part. Means it has de-highlighted those parts. So that is a very interesting thing to note, that whenever you apply a kind of filter, you actually output that you are going to get is going to be a kind of feature. For example, when I apply 111 on this particular image, so I see that what are the items which are actually bigger than of the 3 cross 3. Those items are going to be highlighted. Okay. Those items which are going to be highlighted. Similarly, as I told you that if I apply an enhancement filter over here, so I get this thing. So it is going to be the summation of the difference of this particular quantity and summation of the original image. It is going to give you this thing. It is going to be the sharpening of the image because I have added more details to the image this time. This filter is going to be a sharpening filter. Similarly, there is another filter where 111 minus 8. If you apply this filter, it is going to detect the edges. Okay, it's not the perfect edges, but you can see that these are the some kind of things that happens when you apply a kind of filter to the particular image. Any questions on that? Make sense? All right. So into the three-dimensional space, because image is a two-dimensional space, and sometimes you want to apply the same thing, similar kind of things on the three-dimensional space where multiple channels are there. So if there are multiple channels, because if an image is there, so image would have the R, G, and B channels. If you apply a filter, wish to apply a filter on this particular thing, then definitely on one surface, if you want to apply a filter, so let's assume that you want to apply the 3 cross 3 filter. So I can say, look, let me tell you in this particular way. R part, you can take that this is the R part, and similarly you can take the another array and say that this is G part, and similarly you can say that I have taken the other part and this is the B part. Okay, R, G, and B. If you want to apply a filter, so you need not to apply the same filter on all of them. So let's assume that I apply the 3 cross 3 filter over here, and a different 3 cross 3 filter I have applied to find out the G part. Different 3 cross 3 filter I have applied over here. So one filter, then one filter below that, and one filter even below that. I have three filters over here. How many filters? Three filter I can apply. Then if I put these three filters one by one, I would be getting a box. Okay, I have to apply the filter on this particular thing. So into the 3D space, if multiple 2D vectors you have, on that, if you wish to apply something, it is going to be some 3D filter. Now your 3D size, because you can combine all these things and now you have 9 values. And in the same way, the summation of all these quantity is going to be represented on 1 pixel location. Do you understand this particular part? Yes or no? Do you understand this particular part? Three things were there, or even multiple things could be there. So you can, if you apply a filter on all of them in one go, so this filter is going to be a 3D filter, and it is going to generate only one value out of that. Yes or no? Yes or no? Here I wanted to highlight one thing, that if the number of layer, if I have uh, I can call it depth. If the depth is D, then the filter must also have the depth what? D. Yes or no? Otherwise it doesn't make sense to apply on the thing. Okay, filter also must have the depth D. However, this length breadth thing can be changed. So if I say that filter is equal to 5 cross 5, should I have to specify the depth into the 3D scenario? Should I have to apply the depth? The answer is no. Because if you don't, because if you apply a filter of size say 5 cross 5, so 5 cross 5 value would be there. So this is the 5 cross 5. Okay, this is the 5 cross 5. But at least in all the cases you also must have the D values inside. So how many planes we have? How many planes here? D planes you must have. So this D you need not to specify. It is already specified. So how many values this particular filter has? In this particular case, 5 cross 5 into 3. I would say that I have applied a filter of only 5, of f is equal to 5. I would just say that f is equal to 5. So you would understand by this that the filter is 5 cross 5, where depth is going to be dependent upon what? On this particular, what was the input. So depth is going to be of this particular thing. Once again, who is stopping you to apply, who is stopping to you not to apply more filters? What I mean to say? This is my one filter. Na? I say that one filter is of 5 cross 5. How many values it contains? 75 values it has. So if I take another filter means what? Another set of 75 values. This filter is also 5 cross 5. I can apply one more filter on that. But this is a different filter and this is a different filter. So the second filter would generate something, some other surface out of that, some other output out of that. Okay, there is a question. Output will also have a depth D. No, output would have only single value. Make sense? Output would have only single value. But if I apply multiple filters, as I told you that if I apply one more filter, so how many output would be there? Now we have 2 output. So you apply one more, 3 output you can get. You apply one more, 4 output you are going to get. So you can get multiple outputs by applying multiple filters. Okay. If somewhere you have this much thing available, so see here also you have some depth also available and some length and breadth is also available to you. Mohit is asking question, are we using the same filter at every depth? At every depth, same filter. So I think you wanted to ask that here the depth is 3. Okay. Same filter means that there is a one, for example, here I say that, let me give an example. 1 1 1 1 1 1 1 1 1. I have, let's assume that I have used this on R. You wanted to ask that whether on the G I would also use the same value. Is it the question, Mohit? The answer is no. Okay, you are free to use any other value. -1 -1 -1 1 1 1 1 2 3, anything you can take. What does it mean? It we are not sure right now. Maybe it is going to do something very interesting. We have to find out that. So this particular filter has a depth and therefore it is going to have many values with it and all the values are going to be different. Make sense? So once again, on the 3D thing, if you apply a filter is also 3D filter, but the output is going to be 2D only. The output is going to be 2-dimensional only, 2D only. But you are applying multiple such filters and therefore this 2D output, multiple 2D outputs you are going to gather and by this you get a 3D output. Make sense? Okay. So this is a very interesting slide. I wanted to tell you one more thing, that is a very interesting thing called stride. And what is a stride? So on the same thing, let me come back and let me tell you this particular thing over here. Stride is a very interesting idea. It says that, for example, let's assume that I'm going to apply. mm, so stride, the idea of stride is this, that let's assume that this is an image and you are going to apply f is equal to 2k plus 1. So what I told you, that k values, initial k values you cannot get, then you start getting this first value. Okay, then after that you would get the value over here. After that you would get the value over here. For every pixel you are going to get the value. Is it clear? So who is telling you that after getting this value you go to the next value? Is it possible to go, instead of the second value you go to the third value? You skip one thing. So when you get all these values side by side, you say that my stride is equal to 1. If I say that my stride is equal to 2, means what? That after getting the first one, I go to this one, and then after this, I go to this one, after this, I go to this one. If its stride is equal to 3, it means that after the first one, I go to this one. I think after 3, 1 minute, after 3, you go where you go. From this, you go this thing, and this, you go this thing. Make sense? That you go into this particular way. So very interesting concept, that there is some concept coming up with respect to the stride. What the stride means? Okay. So if I say that I take these many number of items out, let's assume that my length is L and this is B. So let me just talk about the one dimension only. So my length was this. I say that L minus K plus 1. If I remove these things, so these many items I'm going to get here. Once again, out of the first K plus 1 item, please see, out of the first K plus 1, if my length is L, out of the first K plus 1 thing, I am going to get 1. First output I am going to get in K plus 1 thing. Okay, in the first K plus 1 pixels, I get 1 output. And the remaining one, how many of them? L minus K plus 1. Again, here also, I have to leave the K items from the uh, from the from the last, because I cannot take it forward because my thing is fast. So I say that this, if I remove these K items, so these remaining item whichever I have, for every S item I am going to get 1 output. Are you able to see that? So I remove K out of that again, for what? For this particular portion. And using in this particular place, I say that every S item I am going to get 1 item, 1 output. So if I say that L minus K plus 1 minus K item divided by S and plus 1, this is the output that I'm going to get. Plus 1 for, because I have to remove this thing. For these many number of item, I'm going to get 1 output. So this is the total output that I'm going to get. Total number of things I'm going to get. So if the size was L, I get these many number of outputs. If my stride is S, so is it clear? Once again, this particular number can be written in a more fancy way like this, that L minus 2k plus 1 upon S plus 1, which in turn means what? Which in turn means 2k plus 1 is the filter size. I write this particular quantity as F, so I can write this as L minus F divided by S plus 1. And if somebody says me that I'm also going to consider some kind of padding in both the size, if I add the padding is equal to P. So whenever I add the padding, last time also we have discussed this, that adding the P means what? That this length changes to L plus 2P minus F divided by S plus 1. So this is what I actually get. This is actually what I get with the size. So if my initial size was h, it becomes h minus f plus 2b divided by s plus 1. Similarly, the width becomes w minus f plus 2b divided by s plus 1 if the stride and uh, if the padding is p, filter size is f, and h cross w. If I have the image of h cross w, so the next size is going to be this. Make sense? Here is an example. Let us solve this using this particular example where I have a, let's assume that I have a feature vector somewhere where 227 cross 227. This is the, I think, 3 channels. So you can say that the 227 cross 227 into 3. Filter applies 11 cross 11 cross 3. It must be 3, otherwise I cannot apply over here. And let's assume that I have applied 96 such filters. So if I have applied 96 filters, so what should be what would be the depth of this output? It would be 96. Okay. If a stride is equal to 4 and padding is equal to 0, so what is this particular width, W1, W2? Can you tell me? So what is the height? 227. What is the filter? Filter size? F is equal to 11 cross 11. You can see that 11 cross 11 filter I have applied. Plus minus of f, let me write minus, then plus 2p, padding is 0, 2 multiplied by 0 divided by s is equal to 4. If I say that stride is equal to 4 plus 1, this is what the size is. So can anybody tell that what is this quantity? Can you tell me that what is this quantity? It comes out to be 55. So 55 cross 55, it is output that you are going to get. Okay. So I would stop at this particular point. However, few slides were more there. We can, and that actually talks about that what is the use of this CNN on the classification pipeline. We would come back to this into the next class. Thank you very much. Thank you for attending this session.